Okay, welcome, welcome. This is actually the very last webinar of the course. We're almost done. And hopefully the course has gone well and light is at the end of the tunnel. Let me tell you about the plan. So as always, I'm going to start out with any questions that you might have. And throughout, I'll answer any questions you have. Always happy to help out. And so if you have them, you can pop in the chat box. I always have an eye on it. Can also talk. Um, so we'll do that. And then again, this is our last webinar. So today is going to be the very last topic of the entire course. And when you see this, you'll have no idea what it means, but it's ANOVA. And it actually stands for analysis of variance, but we're not going to analyze the variance at all. It's kind of a weird thing. So just remember, ANOVA is easy to remember. And it's really all about something that we have not done yet, because we have already been able to handle a proportion or a difference in proportion. We've been able to look at, many survey questions when they're all qualitative. We've looked at a single mean, we've looked at two means. So what have we not done yet? What have you not been figured out how to do any kind of statistical analysis about? There's a few things, but in terms of what we're doing in this class, there's only one thing left. Any thoughts? Okay, don't see anyone chiming in, so let me let you know. We've been able to handle a mean, we've been able to handle two means, but we have not even mentioned what happens when you have maybe three or four groups or maybe 100 groups and you want to compare the means. So that's what ANOVA is going to be all about. So we'll look at the requirements for ANOVA, and turns out there's pretty many, and it is important that you understand what's required. And then I'll remind you again, project two is due the end of the week, so it's due Sunday, but I recommend, earlier. And I'll also just talk about the end of the class and some of the things you might want to think about. Um, this will be actually maybe the shortest webinar of the quarter because it's just one short chapter, but I'm always happy to answer questions or have any conversations that you want to have. So just let you know that there's not that much topic today. So we might finish earlier than usual. Almost certainly we finish earlier than usual, but maybe a bunch earlier. We'll see. So that is the main thing. I want to give you some reminders about what's up. This is week 11. And again, there's no exam this week, but there is the project, and project two is really important. So it's very important that you get going on project two. You should be most of the way through it. And in fact, I've already read a few of your drafts, which is great. And, please, if you haven't sent me a draft yet, send me a draft. If you've already sent, you can't send twice. Then you just submit the final thing and put it on Canvas, and I'll grade that after Sunday. So that's just a note is that always happy to look at your draft. It makes a big difference in being able to make sure that you take care of all the issues that there might be. Okay, at least most of them. So that is really important. And then I just want to let you know again, this is week 11, and we're officially a 12-week course, but the last week is finals week, so it's not a teaching week. So there will be an exam a week from tomorrow. You could take it earlier if you want. With online, you can, whenever, but you can't take it later. So the course is completely done a week from tomorrow. So that's just a note. There is no webinar next week because there's nothing left to talk about because today's the last day of talking about new material. So that is pretty much it. But I'll go over more details on the project later at the end. Any questions about anything? Any questions? Thanks for coming, all of you. Any questions? There's no questions. Then maybe I'll go on and look at an example. And again, we're not going to do a lot of examples because pretty much there's ANOVA. And we're just going to do the one type and that's it. Okay. I mean, you could do a zillion different examples of that type, but they all do the same thing. So first thing, here's a few things. Analysis of variance is what ANOVA stands for. And you don't have to know why it's called analysis of variance. That has to do with the back end mathematics. Don't worry about it. But it's called ANOVA, and that's what everyone calls it. It's not just me. And what it does is it tests to see if several populations' means are equal or not equal. Okay? So that's really what we're looking at. We're looking at not just one mean, not just two means, because that we know how to do with just difference between mean test, independent or dependent, but we'll be looking at maybe three means or maybe 100 means or maybe 20 means. Um, and that's what ANOVA is. And in terms of H naught and H1, and I want to let you know this is really important, and a lot of people don't listen to the webinar. Those of you who are here live, you're listening. You better be listening at least, so that you hear what the rules are, so you get things right. So for example, on the exam that's next week, um, and that is H naught must be in symbols. Okay, and the symbols are always going to be, there's going to be the first population mean is equal to the second population mean equals the third population mean, and if there's seven of them, you go all the way to the seventh. If there's whatever, then I write dot 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 equals the last population mean. And that's what the null hypothesis is. And the way of thinking about this is all the population means are equal to each other, but you must write it in symbols. Okay? In fact, can you promise, put in the chat box, I will write it H naught in symbols. Just so you promise, so you don't break your promise. That helps. Okay? And write it on notes if you are watching this as a recorded video. So very important to put that in symbols. Hopefully you'll put in the chat box so that you promise. Okay, and then there's H1. H1 is the alternative hypothesis. That part's not new at all, and that one's going to be in words. So that one you have to write in words. Okay, and the words are at least two of the population means differ from each other. Now you're going to be writing whatever the means are about. So population mean, blah, 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 differ from each other. And we'll have an example and you'll see what that is. Okay, so notice H naught is in symbols, H1 is words. It's funny, when I first taught this class, I did H1 in symbols, and everyone was so confused because the symbols were really complicated. So I don't do that anymore. Now H naught in words, H1 in symbol. I mean, in H naught in symbols, H1 in words. Okay, and just let you know, if you don't want to use the equation editor's complicated, finding mu, you can write always mu when you're putting it on, say, the last exam, and that's allowed. We'll call it mu symbols. And then, by the way, this little subscript thing, and then that would be 2, that would be mu2. Any questions on what this is about? Okay, so let's look at the requirements. In order to use ANOVA, there's a lot of things you have to have. The first, we pretty much had for everything we've looked at about this class, and that is the sampling distributions are approximately normal. How big a sample size do you need, do you think, for each of the entries or for each of the groups? How big a sample size do you need to know? Yeah, more than 30, so at least 31. If you have less than 31, you better know they're normal, which you never do. So this could get really hard in the real world. If you want to look at, say, the mean weight of people in each state in the United States, that would be a huge sample size because there's 50 states in the United States. That's times 31. And that's like over 1,500 different people you're going to have to weigh. So that would be a lot of work. Just let you know that. Now, of course, in our class, we just do it in general, but you know, you're supposed to know to do it. Okay, another one that is a very important requirement is all of the population standard deviations are equal. Okay. Now, often you don't know that, so that's an assumption you make. It turns out there are ways to find out if they're close enough to being equal to use ANOVA, but we don't have time to do that. This is elementary statistics. So I do want to give you a big heads up that just because we're in the very last week of the class, that does not mean there's no more statistics in the world to learn. It just means that that's all we can do. And there are statistical tests to test standard deviations, actually, but we're not doing that in our class. Okay, but what you're required to do is just know that if you use ANOVA, one of the requirements, and it'll be an assumption sometimes, was all population standard deviations are equal to each other. Okay. The other one that we've had in the entire course is we have no bias. Okay. If you do a survey and there's bias, then statistics is useless. Okay. It just means that you have a study that tells that really there's no information from it. Does that make sense? So basically, no bias, simple random sampling guarantees no bias. There's some other ways of getting no bias or very little bias, um, but that's actually a hard thing to do. All we're doing is knowing that you're supposed to have no bias. Does that make sense? Okay. Another item that you have to have in order to use ANOVA is that all of the samples are independent. So this is not like a kind of like a paired study we have with with difference between two means, or you could do the same thing with, four things. But so you can't do any kind of pairing or grouping by, where, hey, it's the first person and this first person, first person, second person, they all have something in common. So you can't look at, say, I don't know, families of five and then, oldest, second oldest, third oldest, youngest, and look at each family because those would be not independent. Okay. Most of the time, independence isn't a big problem, but you just have to pay attention. Okay. And then the final one is the samples were consistently taken. Okay. So that one is especially important in the real world when let's say you're a company and you're going to do a survey and you want to look at, maybe like weight of people in the states. Okay. In the 50 different states. You can't do it all by yourself. That's too much work. Instead, you're going to hire somebody in each state and you're going to have them conduct the survey. So it's really important that every person who is conducting the survey is conducting it in the same way. Okay. And to give you kind of my experience from very long ago is I was part of Carol Davis market research firm on conducting studies. And what we would do is the head of the company, Carol Davis, would have a meeting with us. And she talked to us about how we were supposed to do the interview. I did phone interviews at the time, so that all of us would do it in the same way. Okay. And so that was a corporate job I had, did calling people. Any guess on how old I was when I did that? When I was working for Carol Davis Market Research and conducting studies? Any guess? Put it in the chat box. When I started my job. Okay. Here's the thing. Nobody is gonna guess right. Because this was a completely different time. I was 11 years old. And I literally was doing that. I got paid. But things were different in those days. That would never happen now. But I still remember it. Kind of cool, isn't it? So I've been actually doing statistics since I was 11 years old. Okay, I didn't know the math at all. I just did the surveys. Okay, but I remembered it. And we made sure that we all did it consistently. Make sense? Okay, so those are the requirements. And if you don't satisfy the requirements, then you really can't trust any of the statistics that you got from ANOVA. Okay. And again, we've seen this kind of stuff before. Like if you have bias, forget it. Okay. And you have to have a big enough sample size, otherwise, it's really not useful. So now we have a few more things. Any questions on the requirements? And again, you're going to be asked, okay, you're going to be asked to, write down the requirements, what you must assume or whatever, and you better state all five. Okay. So you ready for an example? Okay, suppose a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay? The data from the study are shown below. Okay? And I just want to remind you, when I say suppose, that means I totally made it up. But you can imagine a study being done, right? Okay? And these are data. And I just want to make it easy so we have small sample sizes, but otherwise it's a lot of typing. So we had different races. We had white people, we had black people, we had Hispanic people, and we had people of other races. Okay. And just to let you know that the first person who was white that answered the survey, in theory, said, I live 15 miles from the nearest public library. Okay. And, others, the next person said 4, first black person said 12, first Hispanic person said 9, etc. Okay. And then someone that was another race said 18. And what you do is you collect the data. Any questions at all on this question? By the way, how far do you live from the nearest public library? Put in the chat box. How many miles do you live from the nearest public library? I live 2 miles. That's why I highlighted that. I live 2 miles from the nearest public library. How many miles do you live from the nearest public library? Okay. So you'll notice, and the reason why I'm asking you this is very important in this class, is to know whether you're doing a qualitative survey question or a quantitative survey question. And you'll notice this is a quantitative survey question. All of the data values are numbers. Okay, and if they're not all numbers, then it's not going to be ANOVA. That makes sense? Looks like I'm the closest so far to the nearest public library. And if you count the college as a public library, because there's a library here, it's 1 for me, but 2 for the non-college public library. That's complicated. Okay. Does that make sense that this is a quantitative survey question, and we have 4 different groups that are being surveyed, right? 4 different races. So the first question is, what assumption must you make in order to perform an ANOVA test? So notice this ANOVA seems to make sense because it's quantitative and it's more than 2. Okay. So the good news is all we have to do is restate what we saw. We must assume that all 4 distributions of distance from the nearest public library are approximately normally distributed. And notice that we really have to assume that because our sample sizes are all small. If the sample sizes are over 30, you don't have to assume that because that's guaranteed from the central limit theorem. But if the sample sizes are small, then you have to make that assumption. Okay. Another one is all population standard deviations are equal. And that's definitely an assumption we're going to make. I have no idea whether that would be true or not, whether standard deviation of how far Black people live from the nearest public library is very close or the same as for Hispanics. I really don't know. So it's a complete assumption. Simple random sampling. Again, I didn't tell you how this data was collected, doesn't that I made them up. But even if you did it on your own, you'd have to assume simple random sampling or at least no bias. Then the samples are independent. That's usually not a problem because you probably wouldn't like have a first person who's white, black, Hispanic, and other and have them like as a team. You'd probably just ask a bunch of people and ask what their race is and how far they are from the library, and that's completely independent. Does that make sense? So it's an assumption because we didn't say anything, but it's probably not an issue. Okay. The samples were consistently taken. Okay. That's almost, also probably not an issue because you probably wouldn't ask a white person any differently than you would ask a black person, any differently than you would ask a Hispanic person, any differently than you would ask someone from another race. Okay. But if you would, then they're not consistently taken. Okay. Or if you went to a black neighborhood and asked people in that neighborhood, and you went to a Hispanic neighborhood and asked people in that neighborhood, then there's actually an issue with that. Why would you have consistency problems? Any ideas? And if you went to a white neighborhood and asked people in that neighborhood and a maybe Asian neighborhood and asked people in that one, where would there be consistency problems? You'll see y'all jumping in. Problem is you're going to that neighborhood, and that neighborhood, if it happens to have a library, you can have very different answers than if it doesn't happen to have a library. Do you see that? So in that case, there's consistency issues. Okay, so it could happen. Any questions on the 5 assumptions that you have to make for ANOVA? Okay, so the next step is to write down the null and alternative hypotheses. So H naught colon, you're used to that. And it's going to be mu sub W, so the mean distance, population mean distance from the nearest public library for whites is equal to mu sub B, that's the population mean distance from the nearest public library for blacks, is equal to mu sub H, that's the population mean distance from the nearest public library for Hispanics, is equal to mu sub O, which is the population mean distance from the nearest public library for other races. Any questions? So again, if you can't always do it, but if you can, hey, it's better to use letters as a subscript where you can remember who's who. Okay, which group is which. Okay, if you have too many, then you can't always do that. Because you may not even have, you might have more than 26, for example. So, but if you just have a few, often you can just use a letter. Otherwise, use numbers. Okay, H1 is at least 2 of the race's population mean distance from the nearest public library differ. Guess that should be, yeah. Okay. So notice that, you don't want to just copy the template and like not refer to nearest public library. So it is important that you actually refer to what you're talking about. And here we were talking about races. Okay. And note again, H naught, symbols, H1, words. Any questions at all on the null hypothesis and the alternative hypothesis? Any questions? Okay, what do you think the next step is going to be? Right, we're going to use ANOVA. What do you think the next step is going to be? And we're going to use the level of significance of 5% because this is very sociology type. And what's the next step? Yeah, we'll go to the calculator. So let's go to the calculator. What calculator number are we going to use? And you're going to smile when you say it or when you type it. 26. You'll notice that's our last calculator of the entire course. This is it. Okay. And again, this week is simple. There's just one calculator. There's just one thing to do, basically. It's step by step, lots of steps in the one thing to do. But you don't have to like decide which type of test to use because for this week, it's the ANOVA. Okay. Now for the exam next week could be anything because the exam covers everything. But for this week's stuff, ANOVA is what it's all about. So I'm going to click on ANOVA. And what it says is enter the data values separately by commas. For example, 3, 4, 7, 9, -2, 8. Then hit calculate, and an F statistic and the p-value will be generated for you. Just to note, this is something we haven't had before, and that is the F statistic. Okay? And the idea here is we've had a bunch of distributions, and this is the shape of the F distribution. And it turns out there's two separate degrees of freedom, but in our class, we don't need to go over them. So if you do, then I'll know you're just using AI, and I'm very mean when you do that kind of stuff. So don't use AI. But you'll notice that it is skewed to the right. It's a one tail. Notice that there's no negative values at all. Okay. And if you change the degrees of freedom, it changes the curve a little bit, but not that much. So we're not going to get into the details because there's a lot of details in ANOVA that we just don't do. But this is called the F statistic, which is a test statistic that we use for analysis of variance. And if you want to learn more about it, then you need to take an upper division statistics class, or maybe an upper division mathematics statistics class because it's very, very complicated. And the last thing I'm going to do is go over it because I think you would all scream. But it is called the F statistic. Okay, so we got to put in our data. So I'm going to go, the easiest thing to do, I think. I think I can do this. Let's see if I'm going to try copy and pasting, see what happens. I won't put commas in. Yeah. So 15, comma 4, comma 11, comma 9, comma 3, comma 2. And the next one was 12,166. So I'm copying and pasting. And then don't forget the commas, 12, comma 1, comma 6, comma 6. And the next one was 9, 17, 5, 14, 7, 1. So I put those in. Oops. Let's try one more time. There we go. 9, comma 17, comma 5, comma 14, comma 7, comma 1. And then the last one was 18, 11, 2, 8. Copy and paste those in. 18, comma 11, comma 2, comma 8. Just to let you know that this calculator only has 8 different possible data sets. And sometimes you need more, like, in the example of, states in the United States, that would be 50. This calculator wouldn't work. Then you could use a spreadsheet calculator. That one works actually. That's got a full spreadsheet that you can add stuff to. But this one doesn't work. Excel works. I mean, there's others that can work, but for the class, I'm not going to give you anything with more than 8 data sets. Okay. By the way, why can't I just use a hypothesis test for the difference between means and look at white versus black? Look at black versus Hispanic, look at Hispanic versus other, look at white versus Hispanic, white versus other, and then black versus other. Why can't I just look at all those, and if any of those have a small p-value, then hey, I found a difference. What's the problem with that? Anyone know the problem? Any thoughts? Why can't I just do a bunch of tests for the difference between two means? Okay. I know it's more writing, but I could do it. But why can't I do that? Why would that be wrong? Not just hard, but wrong. Okay, I don't see y'all jumping in, so maybe I'll explain it a little bit. So every time you do a hypothesis test, if they were all the same, and let's say you used a level of significance of 5%, you'd have a 5% chance of a type 1 error. And if you do it a bunch of times, that percent chance of a type 1 error becomes really big. So one of the things ANOVA does in the back end is it handles all that to make sure that your probability of a type 1 error really is your level of significance. Does that make some sense? So you wouldn't just do a difference between means for all the different pairs and see if you got any small p-value, any tiny p-values. That wouldn't work because you got too big a chance of a type 1 error in at least one of them. Okay, so now that we've talked about that, now we can go down. And I tried to make this really simple. You put in the numbers and you hit calculate. Okay, and you'll notice it gives us F. F again is the test statistic, and that's about 0.3339. And our p-value is about 0.8. Okay, you could also see the F distribution looks kind of like this. And this black dot is where we land. And these shaded regions are the rejection regions, and we're not even close. Our p-value is way too big. Our test statistic is way too small. It's tiny. I mean, it's really, really not significant. Any questions on the picture? Okay, so our test statistic, 0.33, I'll go 2 decimals, p-value 0.8. All right, when the p-value is 0.8, what is the conclusion? What's the first few words you have to write in anything that we've done in this class since we started hypothesis testing? What are the first few words you have to write? Exactly words. I've been very clear on it throughout the quarter, but fail to reject, right, but in the sentence, in the conclusion, the sentence that we write. You definitely fail to reject, but what about the sentence? What's the first word? I told you had to use that first word. Do you remember? We've been doing it every week for the last month or so. Insignificant evidence is the fourth and fifth word, actually. The first word is there. So there is statistically insignificant evidence to conclude that at least two of the race's population mean distance, and my grammar is not perfect, so now it is, population mean distance from the nearest public library differ. Okay, That is a template that you're required to use. I will take off points if you don't use the template. And if you don't watch the webinar, then you're not going to use the template and you're going to lose points. If you watch the webinar, take notes. Okay. By the way, the IN, so if we had a low p-value, that IN wouldn't be there and you'd say there is statistically significant evidence. But if you have a high p-value like we did, because 0.08 is bigger than any level of significance you'd use, there is statistically insignificant evidence to conclude that at least two of the race's population mean distance from the nearest public library differ. Okay, and what's in red, and the part I said real loud, there is statistically insignificant evidence to conclude that at least two of the races population mean distance from the nearest public library differ. Those words have to be there. Got it? Okay, if not, you lose points. Okay, and I'm pretty harsh on points on the when I grade the exams. Any questions on this? Any questions? Okay, I want to mention a few things. This is to get you ready for your future when you might take another statistics class. And that is, we have not done everything there is to do about ANOVA. ANOVA is very complicated, and we're just doing the simple pieces. It turns out there's something called two-way ANOVA, and I'm not going there, but you're going to learn that means that instead of just one survey question, you have two survey questions, and you're doing all kinds of weird, interesting comparisons about that. And we're not doing that. The other thing that you might say is, hey, if you knew that at least two differ, could you look at it and decide which two differ? And the answer is not from what we have in this course. Okay? But it can happen when you do advanced statistics, but not in our course. So you can't know how they differ or which ones differ. All we can say with one-way ANOVA is that at least two of them differ, but we don't know which ones. In this case, we just have statistically insignificant evidence. Do you ever end up saying they're exactly all the same with what we've done in our class? What do you think? Do you ever make a conclusion that the population means are the same for all four groups? Could that ever be the conclusion for what we've done? What do you think? Yes or no? I don't see y'all jumping in. It's just one word to type. I still don't see. Okay, maybe I'll just tell you. You don't want to state it. The answer is no, because you never ever accept the null hypothesis for any statistics we've done in our course. So don't ever say they're all the same. All you can say is you don't have evidence to show that at least two are different. That's not the same thing as you know they're the same. In fact, one of the main reasons why don't have evidence could be that we had a sample size of 4 for a couple of the groups. That's such a tiny sample size, it's worthless. Okay? It might be that there's a difference, but you really don't know anything. Any questions on that? Okay. So the good news is we have now done everything that we have to do for this entire course in terms of statistics. Hopefully you have found it useful. And what I want to do now is give you the secret word. And it's 2 words actually. And the secret word is thank you. So I want to thank you for participating in these webinars and for doing the work that you've done in the class. So thank you is the secret word. because I do want to thank you for being good students and, working hard and, putting some effort in. So thank you is a secret word. Make sure you write that down. And it's 2 words. Just let you know, put a space between thank and you. And that is a secret word. Okay, so we're now done with everything in this course for statistics. But there's one last thing I want to kind of talk about a little bit, and that is some thoughts about the project. So I have a list of suggestions, and these come from when I look at drafts, I find mistakes. And if the mistakes happen a lot, then I put these in the suggestions. So again, first thing, remember, project 2 is due on Sunday. I recommend finishing it at least by Saturday. Okay. No extensions are allowed for project 2 because it's a group project. So hopefully the group you as a group have worked real hard and you're really close anyway. But it's not like something could happen to one person, but it's a whole group. So there's no extensions given, but here are some things you want to think about. And also if you have until Thursday at 8 a.m., but better would be earlier than that, to send me your draft if you have not already sent me your draft of your project 2, and I will look at it. Okay. It does take me some time because I have to read it and it's many pages often. And sometimes I'm teaching or I'm sleeping or something. So just let you know, I do have time this week, but not every moment of every day. So just let you know that I can't, immediately get back to you. But here's some suggestions. One is state you whether you're referring to the population mean, okay, difference, or the sample mean difference. So if you ever have the word mean and you don't have the word population or sample, then you have made a mistake. Okay, make sure you are being very specific on which one you're referring to. And I've even noticed that on some of the drafts that I've looked at in the last couple days. Okay. Don't confuse the level of confidence with the level of significance. Instead, look at the confidence intervals that are 90%, 95%, 99%, and state the pros and cons of each. Okay. And when I say the pros and cons of each, I mean decide which is best for the client based on the pros and cons. It's not the pros and cons for the world. You have one client that this is focused on, and based on the client's needs, which one is going to be best for the client? The 90%, the 95, and the 99. You can look at all 3 of them because it's really easy to just change the number and look at the confidence interval and see which works best. And there are pros and cons. If you have 90%, okay, if you have 90%, that means there's a pretty big chance that your confidence interval doesn't even have the population mean in it. Okay, it's 10% chance. Okay. Um, if you have a 99%, you have a very small chance of missing that population mean, but your interval might be so wide that it doesn't tell your client anything. So again, you should look at all 3 and decide based on the 3. Do not say, I'm using a 5% level of significance, therefore 95% confidence level. Those are not the same. Don't use one to talk about the other. Okay. So let's suppose you decided on a 95% confidence interval. Okay. Say if your client needed if your client wanted a 99% interval, but the same margin of error, how large a sample size would you need? And explain the computation that you use to find that out. Okay. And that'll take a little bit of math. Okay. So don't just state that you're using a 5% level of significance based on the type 1 and type 2 errors. Make sure you go into full detail about what the effect and what the damage or the repercussions a type 1 error will do to the client, and what the repercussions will the type 2 error do to the client. And then based on which is worse, that's how you decide which level of significance to use. Any questions on that? And make sure you go into detail on that. Okay. So for the confidence interval interpretation, make sure that you specifically look at the lower bound. And based on the lower bound, what decisions will the client make? And then in a whole new sentence, maybe a new paragraph, look at the upper bound of the confidence interval and then talk about the decisions the client will make based on the upper bound of the confidence interval. Okay, I do want to let you know the confidence interval doesn't just say, hey, this one's bigger. It tells you how much bigger or how much smaller. Okay, the hypothesis test is just, is this one bigger? Okay, or is this one smaller? Or are they different? So make sure that you don't confuse the confidence interval and the hypothesis test. They're different. Okay, so those are some of the main ones, and there's a lot of other things that can happen. But these are some of them that definitely talk about the upper bound and talk about the lower bound. Let me put one more down. Maybe I'll type it out because I didn't put it here and I should. After looking at the p-value and the results of the hypothesis test, would it help the client to redo the survey with a larger sample size? And maybe I should say the same survey. Okay, and survey could just be collecting data. Doesn't have to be talking to people with a larger sample size. Okay, and that'll be based on what the p-value was. And we talked about that a few weeks ago when we talked about p-value and interpreting it. Okay, and explain why. Okay, don't just say yes or no, just fully explain why. So that's another biggie that a lot of people kind of leave out. So those are some of the main things that people make mistakes on. I didn't put everything in that people do, but these are the main mistakes I see. Okay. So again, the focus is, notice, confidence intervals and hypothesis testing. That's the main piece of this project. So make sure that is your focus of your paper. Okay, don't do anything that happened after chapter 10. Okay, don't even think about, say, ANOVA. That's not something we're doing in this project. Okay, and then if you have any questions about the project, post in the project to discussion board, and I'll be happy to look at your question and do my best to answer it. Okay, and I do check pretty often. Not every moment, but every few hours. Except at night, then I sleep for 8 hours or whatever, 7 or 8 hours. So that is pretty much it. This is our last webinar of the entire quarter. We're done. And I want to mention one more thing for the future. Okay. Hopefully you've learned from this class that statistics is useful. It's not just something you do so that you can get your degree and then you never use it again. And I want to let you know that I'll be here, not forever because I'll die eventually. You won't be here. Everyone dies, but I'll be here for hopefully years, a bunch more years. And if you ever have a statistics question, send me an email and I'll answer it. And here's my rule. If it's about your class or about just some personal thing, then I'll always just answer it, friendly and all that. If you have a business and you're doing it for your business, okay, and there's money involved, then I will help you, but there's going to be a financial charge. And here's the financial charge. What I want you to do is I want you or your business to give money, not to me, but I want you to donate to a scholarship. Kind of the amount of money you might pay someone, and that way you can feel good about helping some college student be able to make it through their college financially. So that's what I ask, is that if it's for a business and there's money involved, to take that money and donate to a scholarship. That directly is better than through me, because through me, then I have to pay taxes. If you do it directly, then you get a tax deduction and I don't have to pay taxes. So it's always good. And again, we have a foundation here that does scholarships if you want to be at our college, or any other college is fine too. But that's the one thing I ask is if it's for business, and make sure that you give back because I think that's important in life. Okay. And I do donate to scholarships too, just out of my money. Um, but when you start having money, then it's a good thing to do. Hopefully you agree. Always good to help. So that is pretty much everything I have to say. As again, I told you that it's going to be a shorter webinar and it's less than an hour. But as always, I will say goodbye. I'm going to say goodbye in terms of the YouTube. I'm going to stop the recording and then I'll answer questions after if you want to say it that, when it's not being recorded. But again, thank you all for coming. I'm here to help. And by the way, Wednesdays are a week from Wednesday is the last day of class. After that, course is over. Don't ask what I can do now. Okay. There's no extra credit. You can't redo assignments from last week or 2 months ago. But definitely you have till Wednesday to finish the last stuff. And also if you have missed any of the secret word quizzes, don't forget you have to rewatch the webinar, write down notes, 5 pages, and then email me. Take pictures of your notes and then email me your notes. It should be handwritten notes. So not AI allowed. And then I'll give you full credit for it for the secret word quiz instead of losing. Otherwise, you lose 5% of your grade, of your course grade per secret word quiz missed. And you can go to your grades and see that where if you've missed any. Okay. And that's really important. So I think I'm going to call it a last webinar. I'm going to stop the recording, but thank you all.